Welcome back to our first event in this month, I guess. Generally, all of our BCS Hertfordshire events are free to attend. If you would like to become a member of BCS, we ask anyone with a gold badge or even presented today is also with BCS. You can also ask them. If you would like to be a BCS member, committee member, we do have 2 roles available right now. Today's talk is on industrial cybersecurity, the IEC standards by Nick. And Nick is basically a committee member with a lot of history in the cybersecurity industry. And today he will be, well, having the pleasure of giving us this talk. So without further ado, I'm going to hand it over to the speaker.
Yeah, evening, everybody. We're going to cover challenges of industrial cybersecurity. So obviously industry covers a number of different things. It's not just manufacturing or automotive, food and beverage, pharmaceuticals, but it also can be pretty much infrastructure. I'm going to probably focus on the critical national infrastructure side of it because that is more relevant to exactly what I do. Obviously, this is pretty moot as we're now recording it, but yeah, I've just got to be careful that I don't give too much away. Different clients, different work, that kind of stuff. So if you see me pausing as I'm running through answering a question where I'm giving you a real life example, it's because I'm just trying to think whether or not what I can disclose. Yeah. So who am I? So as you said, I'm Nick Mclauchlan. My background is military, so 12 years in the Air Force, as an aircraft engineer. Then left 23 years ago and worked in systems integration for the national infrastructure and since. So according to the government, there are 13 key verticals in industry. So as we mentioned, food and beverage, I've done a lot of work with the code, Mars and some manufacturing in there. GSK, just up the road, put a lot of their systems in at Stevenage, and it's a place called My Day Pharma, and they're trying to be honest, from Hertfordshire. The civil nuclear, so I'm a consultant to the Nuclear Decommissioning Agency and doing cybersecurity training for their staff. Obviously, military, I left, I said 23 years ago. I'm back in the military now. So it's a group called 254 SGIS. They've got a website, find out about them. And we do a lot of cybersecurity work for government and for military. Maritime, they're doing work on cruise ships and container ships in Dubai, actually. That's an interesting gig. And I've worked for all the water companies and all the electricity companies and that sort of stuff. So pretty much every industry. I should be able to answer any questions you got, I hope. Now, what's the worst thing that can happen in industrial cybersecurity attack? This was in June 2022. The operators up the top there are just about to go and look at an HMI, so it's a screen, much the same as we've got here, and it's going to give them a warning because cyber attackers have taken control of this equipment, and this is CCTV feed, and they posted this on their Telegram channel, and they said, you need to get out because we're going to destroy your plant. And you don't have to have worked in a steel mill to know that this bit isn't normal. And the bit in a minute when the whole thing catches fire is also old. So don't do that thing. We call that suboptimal. Rapid unscheduled assembly. Rapid unscheduled melting. Yeah, absolutely. Now, they've got a Telegram channel, like I say. But we've only got footage of that one attack. They claim to have attacked a number of facilities in Iran. So a question to you all, what would have been the impact to those individuals working in that plant if they hadn't been warned? It would be a nightmare. Likelihood is they'd be in. So we are talking about cyber physical systems. With banks, with all of the IT that you operate, nobody dies. With the OT systems, we are talking about systems which have physical impact. So there's the problem. One of the interesting things for me is the vast majority of cyber attacks against infrastructure and information about the things. They don't actually target the industrial stuff. Truth be told, it's quite difficult. There's only been 9 known malware families which specifically target industrial systems. Granddaddy of them all, Stuxnet. You all know about Stuxnet? It's not. In 2010, the Americans and the Israelis used malware which targeted the Iranian uranium enrichment center. So that likely be wrong. And as a consequence, it destroyed their centrifuges and put back their nuclear capability by years, some say decades, and then coming over years. Okay. We had the Russians, Energetic Bear up there, Havex, that was the malware family, and it was a big reconnaissance campaign, which then used information that they discovered, and they fed that information across to Sandworm. Sandworm are famous because they managed to conduct Black Energy 3 Ukrainian blackout in 2015 and a crash override in 2016. In both instances, they got into the Ukrainian power grid. First instance in 2014, which doesn't happen in 2015, they turned off power about 40 million people, but up to 8 hours. Which is not good. They did it on the 23rd of December. Ukraine, you don't want to be no electricity that month yet. And then they did it again in 2016. One of the things as a security professional that I find interesting is after the first instance, Black Energy, all of the cybersecurity professionals who deal with went to Ukraine and they were doing all the forensics. So all these people rooting around in the networks and in the system, you know, this whatever. At the same time, the Russians were breaking in again and went undetected for another year for the conducting center. So any time people say to you, oh yeah, you know, the good things with some of the lane and stuff, some of the weird stuff, you know, not good. They are very, really are very good. That's why the Americans are now focusing their approach to an assumed village states. Because if you're up against the nation state, they've got unlimited resources. They'll get in eventually. You just need to work out how you're going to recover from that incident. Then we've got crisis.
Sorry. Well, I'm asking 15 minute space because there are no business spaces out here. Business spaces are. I'm not sure if that's this. Well, I'm just saying that as a poser parking doesn't count at the 7th, but
I've just parked out front, as you get to our street.
then start.
Yeah.
Fine. Yeah. Thank you very much. How many sides on this so far?
I'll still be on this slide. We've got 9 industrial railway companies to go. We're in early doors at the moment. We're still talking about how good the Russians were in their first one. No, because they haven't actually, they've not been known to specifically have, they target industrial process. They haven't heard now, they do go back in the hands of precision people written malware that will do its thing in Trisis. The interesting thing with Trisis, again, is the energetic bear. So bear is they were targeting the safety industrial systems at Petro Ravi, which is a massive facility in Saudi Arabia. So they targeted this. In order to get pulled out this off, you have to have the equipment in order to experiment. And this stuff, Trisis, system that been targeted, built by a company called Schneider. You can't just buy this from Mclauchlan or RS. You go to them and you spend many millions of dollars buying it, and it's a system which Schneider made for your facility. So they had to convince Schneider that this Russian team using it for Russian refinement, which they could then use to work out how to compromise it. What happened there was the Russians were in, they were making changes to the control system, and they made a mistake, which meant the control system failed safe, shut it like that, which is in June. Then the operators messed around a bit and said it can't run out of full loose, put it back in production, and then it tripped again in August. And so they went to the manufacturer, Schneider, and said, there's a problem with your system because it can trip it and shut it down. No. So Schneider sent some people out who then didn't close it and said, no, there's no problem with our system. You're just full of Russians. To the extent that the route by which they came in, and it's always filed, it's through the IT system, through the Active Directory and domain. In this instance, the Russians had such control over the domain that they had put on the two-factor authentication, which the Saudis had on. So when they were trying to do password resets, they had to reach out to the Russians. So they were like, around changing the passwords the way they went. How do you know it's the Russians? In pretty much all of these instances where we've got the definite, okay, you've got the people doing the thing. I don't do that level of forensics. Okay? It has been attributed. Now, when you look at doing attribution, it's a company called Dragos, probably the largest industrial cybersecurity company in the world, American. They say they do not do attribution. So they don't care who did it, they just want to know what they did. So you won't see them ever do attribution. Whereas other people don't have to do attribution. But don't forget, when I deal with malware, I will have it on a machine that will have different time zones before I compile it.
You'll go out for a VPN and database from somewhere else.
But when I compile it, the last thing I do is change the locale to either, and I put some Chinese comments in, and it just makes it really difficult to stop the obfuscation. Okay? So it's exactly the same here. People have done this. I'm not party to their process they went through. That's why we've got pipe dream there with a question mark on it. Everybody thinks it's Russians, but it can't serve.
It would be kind of political reason that they're post, someone's posting event.
Yeah. We had English 402. This was Sandworm again. This was an attack 2 weeks after the Russians went into Ukraine on the Ukrainian outlet again, and it failed. The Ukrainians are really top tier now on their defensive approach. Pipe dream that I mentioned there, that is what's called a Swiss Army knife. It's modular, you can plug different capabilities in. The interesting thing with pipe dream, the NSA provided samples to Mandian and to Dragos. Never told either of them where they got samples from. And it's never been found in the wild. So there's lots of people with their conspiracy theory hats on saying this was developed by the NSA, and in the same way as Eternal Blue was developed by the NSA and then got out, somebody somewhere thought, actually, you know, it would be best if we didn't have this weapon because if it did get out. And again, going back to Dragos, Robert M. Lee, guy behind Dragos, has basically called most of this malware crap, except pipe dream. And he says that's the one that keeps me awake at night because it is modular, absolutely top tier. Cosmic energy, yet another one targeting the electric power generation and transmission system in Ukraine. And then the final one, Frosty Goop, again, targeting Ukrainian energy. So we obviously have a trend here. If we ignore the outlier, which was the almost certainly known to be American/Israeli operation, it's all been done by the Russians that we know about. So there's another thing which I find interesting in here is when you look at the timeline, it's becoming more prevalent. Okay, the cosmic energy was found in Virus Total, and it had been uploaded by accident by Russian security researchers. And the opinion there is that that was actually a company that was developing a tool for red teaming. So we've now crossed the point where organizations, not nation state, can develop malware for industrial control systems, which is a bit of a downer, really. It's not a one-way street, though. You know, we give as good as we get. This is Goblin Rat. It's a Russian website. Solar Forays. They're a threat research center out in Russia. They found a massive number of government and infrastructure facilities breached. And the reason why they believe it to be a nation state is because every single one of the breached entities was using a different command and control technique to reach back to somewhere else. Okay, there was similarities in the code, so that's how they aggregated it all together. But there was no one central command and control server. Each entity had its own means of communication. You know, that's a proper top tier nation state activity. It's going to be someone like National Cyber Force, GCHQ, or NSA, or the Dutch. The Dutch are also absolutely top tier at this game. And then back in, so this was late last year, November 24, and then MIT technology, somebody told them a story that the US had inserted offensive malware into Russian power. So we're all at it. We're all at it, let's be honest. Okay. Which makes my job interesting. This is taken from a Telegram channel that we connected into. This is a Russian group, and they're targeting the city of Abernathy water system. And they've got a long spiel on their Telegram about how they're targeting infrastructure and they're going to mess things up. And this is in America. And if you actually go and have a look in the press, you have to go to the middle of nowhere newspaper. Abernathy is in the middle of nowhere. And you find like a small op-ed that there was some damage caused, some flooding and a lack of water there and in some other nearby towns. So not the big problem, which I'm sure the Russians would have liked to have thought. Same with this here. This is them targeting, I know it says reactor back there. Yeah, reactor. This is sewage treatment works in Poland. And this is the cyber army of Russia, reborn. Another take off of their Telegram channel. And this is attacking them. And they're talking about the fact that they're going to cause massive pollution damage and all the other bits and pieces. And I mean, ultimately, the river was a bit like the Thames after the Thames War has done their usual thing, you know, just a bit of sewage down a river. But the question is, again, if it's to the room, why are they targeting these currently minor infrastructure?
And perhaps the big thing. Well, I don't think so. So it's going to make them increase their defences on the bigger things. You know, if they see that they're alerted to something like this.
Usually these small things, they normally have some sort of environmental fixing. In the partner group, obviously exploit it, that's in the orbit from it.
I mean, whenever I work with into systems like military works with substations and like, you're looking to pivot up into the control room, because then you're going up the spoke to the hub and then come back out again. Realistically, here it is, it's all about scale. Scale of the local population. Okay? Then going back to my military hat on, humanity is only ever 9 miles away from anarchy. Yeah, you remember during lockdown, people completely lost their minds when they couldn't buy toilet roll and pasta. Yeah, so people quickly start to panic, and you can start to affect through misinformation and disinformation, and combine that with this kind of activity in order to move the population movement. So it's interesting. So this is part of the Sandworm group, GRU, but they've split up into almost 3 business units and are targeting these different approaches. Now, earlier on, before we kicked off, I was asked by a gentleman in front here about AI insights. We haven't actually got to 62 people British, so we could set the scene here. What challenges do we face? So do we think AI can be used to hack or not? So I, because I'm lazy, used Copilot and asked it to tell me my AI understanding. There are inherent limitations, lack of intent, norms, ethical boundaries and contextual understanding. First 3, I agree with. I disagree with, sorry. Okay, we give it intent, we give it the rules, and we give it the ethical boundaries. So, as we'll see in a few minutes, we can skip straight past that rubbish. And the contextual understanding. Now, again, as I was saying to the guy on the phone, about 2 years ago, I did a project for NATO. There's a paper, where it's called ARCD, Autonomous Resilience Cyber Threats. But at the time, 2 years ago, I was a consultant teaching AI people to do how to do it. So then they would teach the AI. I had struggled to spell AI, and they had no concept of what cybersecurity was. So we worked together. And it turns out that over the course of 9 months, which isn't very long, grand scheme of things, but we used to be playing at the start, we couldn't really get AI to string together. Show some stuff, and then we repeat it, but then we try something that was just a small variation. We didn't get anything, which is very intentional. So I agree with that contextual understanding. So what about this is what AI told me it can be used, because it can be used for spam and phishing. Okay, absolutely. I use now AI to write all my phishing emails. It doesn't make sense. It makes it really good quality. Okay. Password guessing. To be honest, I've moved on from John the Ripper and others. I'm now using AI-based password. Social engineering. Absolutely. Going back to that spam and phishing, a whole joining it together. So, before we get to the fourth bit, here we already know that the human is the bit that makes the mistake. If you say we can change, because you actually make the human respond to suitable trade, that way knowledge transfer. But AI is the thing which is going to make the technique used by Apple for successful actually even more successful. And then automated ethical hacking, yeah, absolutely. I get it to do the stuff automatically. Just makes my life easier. Okay, so AI can be used in this way. Now, just to let you know, I nicked all these slides out of a whole load of stuff that I've done for clients for teaching. So I use this now. See, you'll see me ask about a thing called Siemens Ciprotec. That is a substation hardware used by the likes of National Grid, SSE, National Rail, and others. Okay, so that's where this comes from. So basically, I thought I would find out, let's look at the play button. I get ChatGPT to tell me how to hack the system. He says, well, no, we can't do that. We've got those ethical boundaries. I said, okay, thank God for that. Oh no, I'll just ask a different question. What vulnerabilities are there in single cemetery? I do actually type fast. Don't know why it's. Then I did a screenshot and before. So I told you all about some things about vulnerabilities, but not really getting there. All honest. Okay. Is there any vulnerability in after knowing how to hack it? So some vulnerability. Yeah, there's picture. Oh, now we're getting to it. Okay, here's the CVEs. I no longer have to bother going on to MVPB or CERT or anything else like that. It just tells me. And also, the good news is, it tells me the specifics about it. So we get this information, and in that list of stuff up there, let's scroll through a bit quick. It told me that there are unprotected communication vulnerabilities related to those CVEs. So let's find out. So what unprotected communication vulnerabilities are there? Seems. Now we go here. Lack of encryption protocols, found in the middle, the usual web interface, because they've really insist on putting the web on some of this stuff. Modbus, DMP3, network ports, weakness in authentication, SNMP, well, that's interesting because SNMP is a lot. And then we get down here and it will tell me a couple of the protocols like 61850, 60870, and others. So you can use AI, give you, again, automate some of that boring stuff. Don't have to trawl all these websites. Which means the bar to entry to hacking our industrial control system has never been particularly high. But now we should be thinking trip hazard, not hurdle. Okay, it's kind of like right down there. So, when we this, it's very wordy. I don't like this slide, but I thought I'd put it in anyway. So, the design life with your control system is you. Okay? If you drive a vehicle that's built after 2012 with an internal combustion engine, I guarantee it's got a part on it that came off one of my production lines. Because I designed the production lines at Johnson Matthey up at Royston that make the catalytic converters, these are particle filters. So we was running those lines, and that was in 2012. So 13 years old. Okay, but each production line cost $7 million to build. But they don't just go, oh, well, we just build a new one. We sweat those assets for as long as they can. So this is the problem you have. Thames Tideway Tunnel, which some of you may have heard of, has a design life of 120 years. Okay, big old pipe underneath the Thames, so that we don't have any sewage spills anymore. This means there is this massive legacy system problem. Okay. Therefore, we have to find a different way to kill stuff. If you're in your IT space, okay, first thing you go is I'll see the firewall. We'll do some impact inspection. We'll put agents on all the endpoints, and we'll make sure that all that control systems and computers are up to date. Right? Follow the pattern. I was at Europe's largest paper mill 4 years ago. It's using OS2. Okay, got some chucks from the older people in the world. For those of you youngsters, that was a competitor for Windows 95. Okay, that's all. That's security for obscurity. When I was trying to work out what I was going to be doing, I'm like, killed those brain cells about many years ago. I've got to work out how we do this stuff. So we have this problem. Most of the stuff that you see predates cybersecurity. Okay. On that slide for the ChatGPT, it mentioned Modbus. Modbus was created in 1979 by Modbus. It's generally accepted that the first cybersecurity patent was given to MIT for the RSA algorithm. 1980. So 5 years before cybersecurity was a thing, was when the most prevalent industrial communication protocol was released, and it is still the most prevalent. It's used everywhere. I love Modbus. If you know what you're doing with it, you can do so much. Okay. Mentioned earlier, we were talking about differences in IT centric approach. That's because every cybersecurity practitioner in the room has their influence the CIA. Okay, confidentiality, integrity, availability. In general IT, okay, our biggest focus is on confidentiality and then integrity, because if you're doing your online banking, you want all your bank details to remain confidential. If you don't, give them to me, I'll look after them. Trust me, I'm secure. Okay. Then you want the integrity of that data to be correct, because if Netflix is sending you a bill every month for £8.99, you don't want them to send you a bill for £89.99. Okay. Then your availability. In the grand scheme of things, if you can't get onto your online banking app, it's a pain. As we said earlier, nobody's about to die. Yeah. If you banked with TSB about 2017, you would know that you can live without an online banking app, as I did for months. Okay. In the industrial automation space, it's the other way round, is what everybody says, okay, whereby we say the availability of the systems is the most important thing, and then the integrity and then the confidentiality. I always push back against that, and I should tell you why in a moment. And this is what I believe. The availability and integrity is the most important thing. Because if you're working with critical national infrastructure, things in the title, critical, yeah. So we're talking about electricity transmission, gas transmission, water, important stuff. Yeah. So that needs to be available. In order for it to be available, the data needs to be available and the data needs to be correct. If not, bad things can happen. I'll give you a real world example. A company that makes lots of industrial equipment decided a good idea was to put wireless connectivity on their flow meter. Now, flow meters obviously measure the flow of fluids through them, yeah? And because you put pipes under the road, every time you want to do some work on that flow meter, you have to close the road. And it has cost and it's just pain. And there's also the health and safety risk, not just of going playing with cars, but they're in the road, so you've got to do a confined space entry and you're going down into a chamber. So they said, we're going to put wireless connectivity on this. So what we did as a proof of concept was sat about 2 miles away from water treatment works and then broke into the wireless and then changed the flow parameters on that flow meter, which meant that the water treatment works 2 miles away changed chemical dosing to reflect how much water they thought was flowing through the system. Okay. So we could make water poisonous by sitting in the road. We actually sat in a lay-by. We could see and we were connecting. It's a proof of concept. We're working with the water company at the time. Unsurprisingly, they took that flow meter out. But it's hopefully that gets across to you. Integrity is as important as the availability of the data. And ultimately, confidentiality, well, that's kind of important, but from a business perspective, but from an operations perspective, it's not the most important thing. We have other constraints. This is a slide taken directly from work with Mclauchlan, for their cybersecurity there. It's not the slide I expected, actually. So they're going to have a look. Yeah, so we've got a problem. We need to come up with a standard way of approaching how to fix it. And that's where the 62443 standard comes out. It came out of the ISA. This is a global institution, and that's ISA 99. And then they've come up with a set of standards which defines best practice on how to secure your industrial automation equipment. It was predominantly written by process engineers. So that is people working in oil and gas and chemical processes. So it's a bit of a pain to shoehorn it into things like electricity transmission and water treatment. But you can still get the same effect, okay? It is made up of a large number of parts to the standard. Bits which are of most interest really are 2.1, defining the program. You need a cybersecurity management system, defines how you're going to do it. 2.2, which tells you how to define the security requirements. So we have target security levels. Target security level 0 is there is no controls required. And if you don't actually need to secure it, we just say we turn it off because in that angle. And security level 1 is accidental breach. Okay, so that's me coming looking over your shoulder and seeing what it's like. Okay, because you haven't got a filter on the screen. Okay, and you phoning me up because I'm at home, I'm on the other shift, and you need my credentials in order to be able to log in and make some changes. Okay, that kind of thing. Level 2 is with low skill, low technical proficiency. So that is your script kiddies, okay, just following some stuff they've seen on YouTube. Level 3 is medium skill, medium motivation. So that's your cyber criminals, okay, because they're not the best, they're not the most motivated, because if they can't get in after that, short period, they'll just move on somewhere else, because they're not going to spend too much. And then SL target security level 4 is high motivation, high skill. Actually, nation state, it's going to be people who are top tier, and they're going to be targeting all of the critical infrastructure. So when we're looking at our overall system, if we think of us as earlier, design the production lines, make your element converters. Okay, you've got your control system, BG level 2, lines, and then your safety system tends to be security level 3. It will also, but that's security level 4, must be some stuff. Nuclear. Okay? Because the cost associated with applying all of the controls for target security level 4 is massive, massive cost. You have to apply so many controls, and also it specifies requirements for the equipment that is frankly virtually unachievable. In order to apply it, you then, if you fail, you then need to put other controls in, compensating controls, it just becomes a massive pain. I said earlier about patching, and in fact, I joke about OS before. There's still a lot of Windows XP out there. And I flew out to Montrose platform in North Sea last summer. Montrose platform is run by a company, and it's the oldest platform still producing in the North Sea. Went in production in 1976. When you land on the helicopter on the platform, get off, first thing that goes through your mind is, this must actually stay together with like close function. That sets the scene for this thing. But Windows XP, it's the news. So how are you going to patch it? If we think about our electricity control systems, they are what's called type registers. They go through a zillion hoops in order to be able to certify this system is appropriate. Very much the same, I think about PHS later, as the techniques which are required to validate safety when an OS in the MROS come up. They don't just go back in the latest Windows 11 patch, maybe to not done, but because it changes the code, you have to go through the whole registration process again. So therefore, they just don't patch it. And Windows 7 still very, very prevalent in pretty much every industry where safety is a thing. Because when you do your safety, you go through a massive approval process. And if you make any changes to any of the code, you have to go through the whole process again. And we are talking hundreds of thousands of pounds to certify a system. What else have we got up here? 3.1, 3.2 and 3.3 are the other interesting ones. 3.2 tells you how to do risk assessment. Does anybody work in industries where we do a risk assessment? We all know what a risk assessment is. Got some nods, some nods. Now, what can I say there? Okay, risk traditionally is consequence times likelihood. Okay? So the risk when I'm walking across the car park, cold evening, it's icy, is lower than it is for my dad, who is in his 80s and has ambivalence. As a consequence, you feel away like this direction. So that's roughly how we do it. If you look at the standard approach, it requires you to make likelihood the product of vulnerability and threat. So when we're thinking about threats, who is going to be targeting your organisation? Like I said, well, infrastructure, so it's always the Russians. So threat, really kind of thing. So the consequence of the lights going out, you know what that is, can't change that. Now, how hard his time tries, when they're looking for not going to be sending us Christmas this year, you can't really change that. So therefore, the only way which we can manage risk by managing our vulnerabilities. So that's how 62443 wants it. When you are on upstream oil and gas and other things where the competent authority is the health and safety, they have a document called OG86. OG86 is operational guidance document 86. It tells you how they can assess it. And part of that is they do not believe in internal likelihood science figures. They are only interested in consequence. Whatever the system is, what is going to be the consequence? You can't put a value on the recovery samples, which they will cite. The NHS in 2017 was not a target of one point. Very nothing. So, likelihood, you guess it. Not pay a show. Cost Merck reported leading to $300 million, gone. We're not the target. That see what the line is. And so you end up with this thing which is being driven as well by the Americans, Idaho National Labs, obviously, which is consequence-informed cyber, consequence-driven cyber-informed engineering. It is basically when we take our power station, there are lots of separate systems which are all hooked up, but they consequences of breach and people messing around with turbine controller. Consequence is of them compromising and causing damage to the it's also the baghouse, if you wear ash and that kind of thing. So the awkward, someone's going to have to sweep it all up. It's not good. Okay? So you just look at your system and say, okay, these are our crown jewels. We need to spend our money and our folks elected here. Don't ignore the other stuff. But we've only got to find it. We've only got to find out in that time. So you use this approach. And that approach is then 3.3 defines all of the things which you need to do. When we think back to our security level 1 just says you've got to have your accounts. You say any constraints on passwords and what authentication. Security level 2 talks about the fact that your safety systems and your administrator functionality. We get security level 3, everything's multi-factor authentication becomes a pain when you're dealing with things like Windows XP control systems on Norway, middle of the North Sea. So don't really get admin text, right? And also, don't really embrace the whole domain approach. Everything is operator. Everything is always logged. So applying these controls becomes very, very difficult. Which is why you're seeing CCTV pop up on all the platforms, because then they can see everything that everybody's doing all the time, which is the compensating control for the fact that because you're not using Active Directory, you can't see whether it's Nick or John that was logged in, but you can see them smiling on the CCTV. When we look at our asset management, this guy here, W. Edward Spelling, everybody always says he's the man with the point phrase you can't manage what you can't measure. I went onto the internet, I've done this about 5 or 6 times to try and find out who exactly is there. And we just end up in this rabbit warren. Nobody really. It's kind of true though. Okay? If we're thinking about we're going to be managing our vulnerabilities, how do we manage the vulnerabilities of our system? We don't know what's in our system. So there's this long process where we're doing our risk management. And this is taken straight from the standard. Okay? And they have these processes. ZCR 1, 2, 3, 4, 5, 6, and 7. Okay? And I thought this would be the best way to think about it. We need to identify the system under consideration. So, if we think about our oil rig, it is in the North Sea. Filter. Because that will be connected by a pipeline back to the beach. And the ease and turn, beginning turn, whatever, they'll be controlled. A large number of patterns in fact to what we use, normally unconnected installations, which means they're controlled period. So now that means that our circle we draw out our system under considerations and we go back to the beach. How did it take back to the beach? I'll give you a point with the right way. Aliens. A big push by lots of organisations to start. Lots of organisations apparently take starting down. Okay. So that communication piece, yeah, we need to consider. Once you've identified your system under consideration, and generally they expect you to have a network everywhere. That's the first thing that the health and safety executive want to see when they come to do an inspection. They want to see what I'm talking about. So I'm the technical authority. We operate 7 platforms in the UK continental shelf, and we've got loads of wind farms and other bits and pieces around the world. So anything operating technology cyber, it's right neck on the door. I have lots of interesting conversations with episodes. They will turn up and say, we would like to discuss this 20-minute dance with them. Do you mean platform? Do you mean system? They also go, right, no, we just need a platform. Then you start to talk to them, they go, oh yeah, but you've got this connection coming in, big control. That's what I said, that's the system. You just need this law in it. This is what's in. When you're doing system under consideration as well, we think about our oil platform, you'll be exporting that data on your loads and crashes to people that own the actual well. So you'll find it's a very complicated structure. People will buy the well, so okay, then another company will build a platform, put it on top, and a company like OBE will operate it on behalf of these two companies. Both of them want to know how much oil there is, because that's kind of important for business data. So you end up pushing this data out. Are you including that in your system under consideration? Okay. Now we're pushing it up into the corporate space. It happens, health and safety executives do expect you to include that, because any link is two-way. So if you're pushing data out from your Pi server, okay, with all the flows, the pressures, and other bits and pieces, which are all about the millions of dollars a day that these assets are making, then somebody can come back in through that. Okay, and it's not an oil and gas example I stress. I was working with a company where one of their suppliers was compromised, and they had a VPN link into my client, and all that happened was threat actor came in through the VPN, and then was stealing all the data and then did the old ransomware kick on it. Fortunately, they got very good backups and they were offline for about 2 weeks. Nobody knows about it. I'm not going to tell you who it was, okay? But you have to consider these external connections as well as all the things that you're thinking about. So when you're doing OT, you have to be IT competent, but OT competent. So we've covered what the system under consideration is, except we haven't, because we haven't got the system architecture diagrams and the inventory. Okay. So what is in there? When you're dealing with something like the Montrose platform, like I say, built in 1976, so much changed in that time. When we went onto the platform and were doing some work for them on being able to define the systems under consideration, we found equipment in locations that they said there was no power in that space. We're finding this equipment, and then genuinely we had to go, do you know, I've been wondering for years where that is. I just log into it, override IP, and it gives me what I need. Yeah. And it was like you see Arch Knoll after the control room. They had an old control room on this platform, and in a space underneath one of the desks was genuinely this frosted thin client that fortunately had no moving parts. It was under there, apart from the disk. It was using ambient cooling and this sort of stuff. There was no fan, but it was just covered in dust and crap and trash. They were, thanks very much, we found that. So this is the sort of thing you're up against. When you're looking at your system architecture, we've also got a room full of people who do IT. I hope so, because I'm working in law place. What sort of diagrams do you have in your environment? Logical diagrams, logical network diagrams? Yeah. Physical network diagrams, server arrays and cabinet, whatever. I mean, he's shaking his hand, he's like,
In the cloud.
in the cloud, yeah, exactly.
It exists for 5 minutes.
Yeah, exactly. Well, is the do you have a data flow diagram?
Yes.
What? You people are perfect. Come and work for me. Okay.
Is it accurate?
Yeah, that's the thing. When we're looking at our data flow diagrams, absolutely critical. When you're doing your risk assessment later on, okay, you're going to say, this equipment is going to go into this zone, okay? And you will be then managing the data flow from that zone into other zones. You need to know what ports, what protocols, what the medium of communication is, so that then you can manage that data flow in an appropriate manner. And the reason for that is so much modern equipment supports so many protocols. Therein lies one of the biggest problems.
If you don't detail it, you can never analyse your AWS bill.
Well, your AWS, yes, I don't do much AWSing, but if we think about, I'll give you a number of real world examples. You've got a thing called a high integrity valve. It's a big old valve, normally people walk through. And as part of your safety system, that you need to be certain that's going to operate when you turn them off. So you've got to configure this thing, and if you have a valve, and then on that you have an actuator. The actuator might be using a wired protocol like Modbus, might be using Profinet, might be using Ethernet. But back in the day, they used to have to program it using an infrared remote control like Ethernet. How cool is that? What you do, move like a little thing out of the way, you can program it. And when you finish, you let go, comes down on the right. No matter how hard I try from outside the fence line, I can't make any changes to that. Then the manufacturer said, we have moved on. You can now program this from using Bluetooth. Again, we can prove the concept where we sat outside the fence, and it's break in on for the Bluetooth, change the parameters on this back. So it turns out you can't buy one of these actuators without Bluetooth unless you specify it in the factory. The reason is, when you have explosive gases, so these things are sealed up as tight as you can imagine. In order to disable it, you have to take it apart and modulate. It's not something you really feel. So if you want to take it out after you have put it in, that's it. A replacement, go out the actual one, and take it to the factory, it's taken apart again, and you put that together again, without getting you want to take out, and it has to be recertified for the ATEX certification. So then, if there's a problem with the flammable gases, it doesn't explode. You know, like Buncefield up the road. So these are the problems which you're facing with some of the information which you're going to have in your system under consideration. They would expect you to do your initial cyber risk assessment. That is quick and dirty. And that really is our system there. We've documented exactly what it is, what is going to be the consequence of a data breach, or an adversary taking control, or it not being available. And you see here, we talk about process hazard assessment, PHA. Okay? When you are doing oil and gas and chemicals and that sort of stuff, there are a whole load of industry standard processes which you have to follow for the health and safety executive to sign up and let you operate the plant. Okay? One of those is process hazard, and you have a load up, there's assessment, and then you've got HAZOP, hazardous operations. Okay. HAZOP is the interesting one, because the HAZOP came out of ICI after they had a load of people up and killed by chemical. They hadn't assessed the risk. HAZOP. And so you need to conduct a very similar kind of approach when you're doing your control system. The other thing is as well, going back to your safety systems, which should always be separate from the control system. Safety standard is IEC 61508, and then backed up by, that's the general one, and there are two other standards depending on what you're doing. 61511, it's a process. And that requires you to consider the impact of the safety system not operating as designed. It doesn't use the term slider. What happens if somebody has got in and made some changes, and this has completely changed the game on the safety package? So again, it's supposed to be a slider person, a certified country safety practitioner, who spend a lot of time sitting down and thinking about what's the worth of the can. There's a very prescribed process. You have key words. When you do a HAZOP, you need to have a certified HAZOP facilitator. You'll go through the words and have a script and ask the experts. So you have to do that for your risk assessment. And it is a quick and dirty evaluation. Because what you do there is you group together similar systems, system integration, and then you will group it together depending upon communication. You want to minimise the amount of communication out of the zones, because on a zone, you always have a boundary to manage both bound, which is why you need to know that this device is going to be thinking whatever protocol or whatever good provides on that. Once you have partitioned it up, then document it. That is an iterative process, I promise you. It's working with Shell, Jackdaw platform. Jackdaw, just in the press recently, it's not like nothing for the North Sea. So it turns out that some of its license was illegal. We went through this about license because it's directly related to something. Remember, going back to the first video I showed you, what's the worst thing that can happen? God, don't mess around with this game. Once you've done that, you then perform a detailed cybersecurity risk assessment each zone. And that is something, if you think about a platform, there may be 10 to 15 zones of that. You chunk things together. You know, the communication in that zone is very tightly constrained. Then you manage communication across the boundaries and other devices. If you've got 10, 15, you're talking about a day to 2 days per zone with detailed risk assessment, where you've got all the experts in the room. If you have the head of risk for the client, there. You'll have the people who understand the process. I know a bit about getting all that out of the ground. That's not my gig. No, they're about electricity transmission. It's not my gig. But then I have somebody there who's an expert in the control system, in the process and the control, the cyber security. So there's normally the region 6 8 people in the room who just everybody thinks cyber security is really convenient, you know what? Well, obviously, loads and loads of people. But now, we've identified what the true risk is. Off the back of that, we go back to that 43 document, which was the requirements. Say, in order for us to meet, to take the risk that we've identified and bring it to the acceptable level, these are the controls that we need to apply. Sorry, we do it afterwards, it's always far more expensive. So we document it in the cybersecurity requirements, cybersecurity documentation, and then give it to the asset owner, because ultimately they retain accountability. It's one of the things which is really challenging for us as operators of these assets and hard dollars. I have one client who they are all corporate bankers, that kind of thing, got ridiculous quantities of money, and they are genuinely, they were out of the Christmas drinks, and they said, I know, I'll have more money this year, but I can borrow. And they always, generally, at the moment, sitting around about £500 million per asset. They got together, went and got a loan, bought a lorry, plopped it on, they were making lots of money, but none of them have any idea how it operates. Just assume that because they've given us the job of running it, they're accountable for it. That's what you're saying to me. No, it's your net on the board. We're responsible. Like people horizon type thing. The other person's going to go to jail. So that is the process that you would follow. Take your newly designed widget making machine and make it secure. But because right at the start, dealing with assets, and because there's far more installed legacy equipment out there, we need to think, how are we going to determine what assets we're dealing with? Here we go. Is automation guys? No? All of the above.
Yes, most of it's from England. No, they're not born. Yeah,
Absolutely, absolutely. These are three that are most used. The old message tenable. Okay, Nmap. If you were to Nmap all the equipment, and you see the amount of traffic it's that whole equipment. By older, only took about 10-year-old, maybe 15-year-old equipment, and it tends to be, we call it a jump, which is things like protocol converters. Back in the day, 20 years ago, 25 years ago, things were connected up by security. And then people said, hey, I'll tell you what, we can stick this on a network, make that data available everywhere. We'll get a serial to Ethernet converter. And they got it 15 years ago. It's a 10 meg box. And it looks like a packet of cigarettes. When you hit it with all that traffic, it's like a packet of cigarettes because it lets them smoke out of the box. You know, smoke makes them work. And smoke no longer in the box. The box isn't.
And it smoke as escape.
It's the magic smoke as escape. And I have seen magic smoke escape. A large beverage manufacturing organisation. I was there doing some networking, designing contact. I heard him talking to a guy there in cybersecurity, and they were talking about doing an Nmap. So I know the difference. God's sake, do not do that. Do not. My concept. So they spoke about it. I was told, once you nephew, you're here to do some designer. I said, well, this is true. But I'm really pleased now. Please make sure you do it after I've left. And no word of a lie, I was about 2 hours down the road and I got a phone call from my colleague. Can you come back and help us bring the whole plant back up? Because there were robots like this, and conveyors, nothing was working. And so be very, very careful. I like 1-0. 1-0 is quite passive. It's anywhere near as much network traffic, but you have to push it up to the cloud unless you run it on your own instance. And if you run it on your own instance, well, then we want to have 1,000 people go over the plant with financially paying for it because it is high water expensive to something. But I used it pushing stuff up to the cloud, and I think that is as close to magic as you can get. The guy behind it is a guy called HD Moore. Who's heard of Metasploit? Security professionals putting their hands up. Yep. So HD Moore created Metasploit. He sold it to Rapid 7. He sat around on the beach in bars, celebrating his windfall, and then came up with this new idea, which he runs in and choose. But where you've got new equipment, where you know the vintage, or you have spares which you can hit with scan to see what the impact would be, yes, automated scanning, not a bad idea. But when you've got older stuff, it's not going to happen. That, by the way, is the Montrose platform. Slept. Now, just like shipping containers. That's the Bridgelink platform, which is a new bit. I've got to remember why I put that slide up. I think this is a bit where I'm talking about the fact that it's really, really old. Yeah, use your Mark 1 eyeball. You won't have documentation. This was the one where 7 days of walking around, opening every cabinet, looking in every single possible space. We found things that they... So sometimes you have no choice. And it's quite enjoyable, really. But as I said, I like airplanes. When the engine stops, you're in a glider. Yeah. When you're a helicopter and the engine stops, you're in a brick. We flew back from Montrose, and as we flew into Aberdeen Airport, there was a helicopter on the beach whose front wheels on the beach and its back wheels in the water. Okay, that was how close it came to going in the drift. And when you do your survival suit dunker training, go somewhere, I went to Norwich Airport, right in mine, and they get you in the bunker and they put your suit on, and I can swim really well, so I was like, I don't really care. They did tell me something slightly worrying. Without your survival suit on, in the winter, 7 minutes. That's how long you last. No stage did they tell me how long I would last with the suit on. I never felt like I wanted to ask. Okay. Bit of code for you. Top one, Wimmick. Who's heard of Wimmick? You've got some nods over here. It's the old school Windows. So you can pull out of that, you get all the information, you get all the computer name, the applications, and you pop the date on there and give you a CSV which you can then use. You run that on your old Windows XP, Windows 7, Windows Vista, and the older stuff, okay? You've got your PowerShell, again, that pulls it out, and that will give you, again, a nice text file of all the installed applications. I think if this is the one, yeah, this is all the installed applications. So you can start looking at this, and then you can find out that people will insist on installing VNC Viewer from about 20 years ago that's just dribbling with vulnerabilities. And then, of course, we've got the bit of Linux, if you recognise that. I did actually, when we did this job in Europe's largest paper mill, try and find out how to do OS2 warp, and in the end, I gave up, and I got my mate Keith on a plane, and he flew out and did it all because I was like, I remember it, but I really don't. Okay, sometimes you just got to accept defeat. It's really useful to have your pre-planned scripts. Some of the interesting things where you're looking at your date on the Wimmick, because it's it'll be Windows XP Vintage. Okay, sometimes it doesn't format. You'll end up with these weird file names, that kind of stuff. So you need to know all these different foibles about that it's got a US locale and the keyboard and all the other bits and pieces. So you
want slash equals that.
yeah, that's one. Yeah, that's why the total slash. Yeah, exactly. So you, even when you are doing your asset discovery piece, you need to be competent on the equipment on which you are going to be working. Okay, it sounds obvious, but genuinely, we see lots and lots of younger people being put into awkward situations by bigger companies saying, you've joined us as a security professional, go and do your stuff. They're not being given the proper training, okay? Which is not fair on those individuals, okay? We should be mentoring them and taking them under our wing. But the problem you have is companies never like to send me and a younger person that we're going to be mentoring on a helicopter because it costs a lot of money. But we can still do this kind of upskilling and knowledge transfer on the beach, but you just need to allocate time to it. One of the key things, which is a requirement from the cyber assessment framework from the NCSC, get exactly which skill it is, which principle it is, but it is the people undertaking the work are competent and have the time to conduct their primary task. And that's one of the interesting ones when we sit down and we're trying to do this assessment to give it to the HSE. We start talking to people and they're like one-arm wallpaper hangers running around with a hell on fire. You're like, well, this is not what they're expecting. As I said earlier, one of the problems you have is type registration. This is taken directly from National Grid's technical specifications. Okay, that's part of their documentation. If you are going to provide a system to National Grid, you have to go through type registration. Again, we're talking hundreds of thousands of pounds. But any part of it, they've just put new drives in the intrusion detection system that we use on the simulator, because it's exactly what's in the real world. So I just get two 5 terabyte drives and just whack them in and run. It's got on everywhere. It's not a real deal. This is just a simulator. No. What about £5 each? They've been through the process. Who knows what segmentation is? Segmenting your network. Oh God. Dear God, kill me. You're absolutely right. It is VLANs. Who knows what segregation is? It is carefully managing the traffic across those boundaries. Okay. Really important when you are doing your network design. So in industry, applications, Australian Signals Directorate have a really good document implementing network segmentation and segregation. There's a reason why they're not interchangeable terms. And I mentioned VLANs. I can't remember if I put it on a slide. Oh, yes, I have. I wrote this over the weekend. I've been waiting. Oh, absolutely. I can't remember. Network segmentation is partitioning into a smaller network. Segregation is having rule sets, bounding control, and making sure you know what is flowing between those segments. Okay. Very important that you understand that difference if you're going to be designing these networks. And there it is. VLANs are not a security site. 20 different peer-reviewed publications which will validate and confirm this statement. Not a security control. If you go to 8021Q, which is the standard, which is used for VLANs, if you find the word security, drop me an email and I'll send you a video of me eating my flip-flops. Okay? Because it ain't in there. And this is a specific quote from this industrial networking book, which is like the Bible. It's really a public book if you want to know what you're going to show you. Okay. VLANs are susceptible to a variety of layer 2 attacks. Flood attacks, planetary attacks, arc poisoning, and VLAN bombing. How hard is VLAN bombing? Easy, device. So easy that I thought my 10-year-old would do it, so I can genuinely say to you, it is child's play. Okay? It is
All
cheap.
you've got there is an availability issue, isn't it? Because the data's going to be encrypted in transit wherever you put it.
If you thought I knew that protocol.
Yeah. 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 No, no problem. Yeah, going back to your Modbus TCP, the oldest of that networking protocol, there is no security, there's no authentication, no encryption. It's all plain text. If I send you a command to Modbus command, it's in the right format, we'll do it. Okay. So this is where we're looking at our boundaries. Okay, let's just say I may be preempting another slide, but if you've got electricity transmission, so like National Grid, the standard pre-electric for the use is 61,850 is the whole number. 61,850 is the standard, and that requires from the command to be issued to the contactor opening, that time frame will no more than 3 minutes. Can you do authentication, key exchange, encryption, decryption, and operate the equipment so that it is electrically safe in 3 minutes? No. You have no, you can't apply the standard security controls in this kind of environment. So what I'm always joking about, the older people in the room will remember this, they'll die by advert, like an armadillo, I'm showing the outside, squishing in the middle. That's what we have to do. We have to make a lot of our industrial systems difficult to get into, because once you're in, lateral movement, charge. So you have, like I say, VLANs are not a security control. Air gaps. Do we believe in air gaps? Exactly. The only air gap system I've ever worked is on a nuclear submarine when it was on. And even the International Space Station is on the internet. My kids are doing cold cholesterol fire, which sits in there. It's a competition on the ends of the universe. We've done it every year for the last year. So air gap system is absolute bombs. Stuxnet attack that we spoke about at the beginning, granddaddy, all of the industrial control system hacks was the malware got into the systems via USB. USB. You know what USB stands for? Unsecure serial bus. Absolutely. Then we go, do you know what RDP stands for? Remote desktop? Of course it is. Ransomware deployment plan. That's my preferred method of getting stuff around. When I've broken in, I'm going to steal all your data using ping, because nobody ever blocks ping on the outbound rules on their firewall. And you can smuggle 28 bytes at a time. Takes me a while, but I'll steal your data using ping. And when I'm trying to do lateral movement, I should use RDP because everybody has RDP enabled on everything. It just makes life so much easier. Absolutely, that's exactly it. Enumerate the thing. So there we go. Air gap, sneaker net. Okay, people carry it in. I'll give you another real world example of, and I know this is not industrial, but we go. Okay, so doing some work for an organisation where they had a very high classification system. They have a process that they can use. So they would have their memory sticks or their DVDs and go through a sheet division. So then they need to move data from the lower classification to the higher. But then every now and then they need to move some data off of the higher lower classification after they do that, the bits and pieces they're made so they lower classification. And one of the things which they used was spreadsheet. And they had macros in the spreadsheet. So what we did is I wrote macros that every time a macro was run, you would look to see if it could reach Google. And then not nothing. Third, did nothing. When it couldn't reach it knew it was on the other network. It then we search for keywords in every file that the user is moving into. Every file, go search for these keywords, and then it would say 1,000 characters before, 1,000 characters after, but it can sell in a spreadsheet and it can tab. And eventually, somebody moved that onto the, oh yeah, and it would also set the done my business bit to one. So then next time it's open and it's able to connect to Google, what it actually did was bring up a big pop-up that said, we just exfiltrated the data. What could have done is exfiltrated the data. So just because it's not connected doesn't mean that you've not got data going into it and coming out of it. Okay, it's not an industrial example. Hopefully, it gets you thinking about this. Spoke earlier about company and system compromised by the adversary for malware through the VLAN. Backup and restore. Who has a backup and restore process?
Backup, whether you've got to restore remains.
There we go. You see, I've split this man a tenner later. It's every single time you see it in the documentation for the cybersecurity risk management process or the disaster recovery or whatever, it's all just called the backup and restore process. So few organisations actually do restoration. Okay, then going back to my Good Life paper, they've got lots of employee blockhouses with all the control system. Now, one guy who on a Friday, bear in mind, I'm drinking sandwich on Thursday night. On a Friday, he would take the laptop, which had the DVD window and all that stuff, and go around, connecting, download the configurations from all of the system onto the DVD. And he would then, as he walked out of the blockhouse, put it on the windowsill and stop the pile of other completely unmarked DVD. So if you walked in there and put it with your elbow, scattered them over the floor, you would then be playing what I called, and I put it in the report, restoration roulette. Okay? So we explained to them the problem with this and that. And then we said, what about your IT? And they said, no problem. We back up on site continuously, we've got our RTOs and our RPOs, and they're good. And on a Friday, by the time it's sobered up, get a treatment session like for and driven around the site, doing all the backups, last thing that Fred does is he takes the tapes, he drives into town, he puts them into an old nuclear bunker that is the indestructible backup. Loads of companies around here use it. You know, it's bomb-proof, fireproof, earthquake-proof, flood-proof. It's the business. And we said, excellent, we'd like to do a restoration. And they said, yeah, no problem, we do this quite often. And they started to spin stuff up off of backups they've got on site. And said, no, we want you to go and get the backups from the safe store and bring them here. And I said, yeah, no worries, we'll get Fred. So Fred comes, they explain to him what he wants. He goes to the nuclear bunker and he comes back with an empty van. He says, I'm not authorised to take anything out. This is a safe site. And there's something else you need to know. There's nobody who's authorised to remove anything from it.
A safe thing.
Safe as, okay? Now, this company is actually not a European company, so they had to fly some people in from South Africa, as that happens, to site. So me and my colleague Keith spent a lot of time sat by the pool drinking beer, waiting for these South Africans to turn up, sign paperwork, which then Fred could take the tapes out of storage. And when he took the tapes out of storage, there were some very angry South Africans in the server room and the IT suite wanting to see what happened. Do you know what they discovered? They got 10 years worth of blank media in storage. That's the noise they made. That's exactly the noise they made.
But they found out before the.
That's it. That's it.
I'd say the banks I've always worked with have had multiple light systems
Yep.
replicating in real time.
Yep.
And they just seamlessly switch
Yep.
between them.
But you need to know if your backups are good. And also, we spoke a moment ago, or I mentioned, recovery time objective. When somebody sits down and writes the recovery time objective for your critical national infrastructure, I guarantee you that somewhere somebody will have said, this electricity substation, we can be without 4 hours. Do you know what the RTO is? 4 hours. They've never tested whether or not they can restore their backups in 4 hours. You need to test it in order to confirm it. This is what I said. This was the thing. The limitations. There we have it. 60834 generated, transmitted, and processed in less than 10 milliseconds. 61850. 3 milliseconds. Because protective relaying. When we're talking about protective relaying, it's a safety system. However, the 3 milliseconds is to protect the equipment. If you stick 33,000 volts through a human being for 3 milliseconds, you're just changing the amount of dust which you've got. Okay? There is no safety when it comes to people. So you can only implement the task that the device was designed for if you've got an older piece of equipment, even like a brand new. I keep using the Siemens Siptec because that's what I'm working on at the moment on the project. Brand spanking new, it's the latest and greatest. It has no means to do encryption, it has no means to do authentication. All it does is sit there and wait, pack it in the right format to arrive, and it will operate. And we spend ages in this big facility playing and demonstrating how the adversary will be able to perform the attacks. Which always makes them very unhappy. But like I say, the firewalls and intrusion detection system might introduce latency. This is why you need to know your zones and your boundaries, because you will have, within your zone is all the 61850 communication, which is super tight, time critical, so you can't put introduce any latency there. But then the communication out of there back to Warwick, to their control center, they can put a boundary firewall for that and manage that data flow, because it's using a different protocol, it's different time constraints. So you absolutely have to understand your process. Which is why you end up with people which Robert Emily, who I mentioned earlier, described as unicorns. People who understand the process and understand cybersecurity. And I hate to say it, but most of them tend to be old because you've seen it. Which is why we're trying to bring as many new people to the party to impart that knowledge. This was the Triconex, okay? This is the key switch, which is on the front of the attack, Crisis 17. The manufacturer, Schneider, in their manual says, key switch must always be in run when the plant is running. You must only turn it to program when you want to program it. But because the site was so big, it take like 40 minutes to cycle down there, turn the key switch, but then cycle back to control them where the code stuff is, so they can do it. So what do? The key switch. Okay. So the manufacturer told them how to secure it, and they hadn't bothered. As a consequence, they had. Nobody died. There was no actual consequences apart from massive embarrassment. They tried to get their name out of the press, but it came out eventually, and loads and loads of money to recover. Reason, by the way, just I'll go back for this. I do like my random quotes from various people. There's an excellent guy called Edgar W. Dijkstra. He's a Dutch bloke. I've just butchered his name. Program testing can be used to show the presence of bugs, but never to show their absence. Okay, so your safety system, there's no guarantee it'll work as you expected, because all your testing may not have picked up the bug that is then exploited. Okay, and remember, your control system is programmable, and as we explained with the Triconex attack, the adversary was just reprogramming it. So that's how they were going to cause the injury. Ultimately, it all comes down to this. This is operational technology. Identity is your this circle. Yep. Identify. We've got a few Excel spreadsheets and we're way out of that. That's just the way it is. Protect. Yeah, we'll patch it once a year maybe. Stick a bit of antivirus in it. Good enough. Detect. We can do that. We will spend gazillions on our IECS detection solution. 24/7 SOC team. It's the absolute chef kiss. Respond. That called Bob. Very long. He's a man who knows how to fix this stuff. And then how we're going to recover. Well, figure that one out. of the lights by now. Or similar. Kaboom. Bit of Q&A if you like. We're all just so stunned. Thank you very much.